All right, so we would like to do 32 and 1.1, which says I've got a picture of fuel consumption as a function of miles per hour, right? So my car going some set speed gives me some kind of fuel economy, and it should be noted that this picture is both. Because if you are going 0 miles per hour, there is no way in heck you're getting 20 miles per gallon.
What
right?
if it's on and you're just sitting there?
Yeah, that's what it means to be going 0 miles per hour.
Yeah, but it's still
running.
Yeah, it's still running and it's not going anywhere.
Yeah.
You guys see that? So you should be getting 0 miles per gallon because you're not moving. You guys see that? So there's something a little bit funky about this picture to start with. But they want me to answer this question. So I want to go 300 miles at 40 miles per hour, right? I want to convert this to gasoline, right? Okay, so how's my car do on gas at 40 miles per hour?
Like 20.
28.
Yeah, the 40's in here, might be like give or take 28, right? So out of my function, I found out that 40 miles per hour as an input corresponds to the output, something like 28 miles per gallon, right? Okay, so at 28 miles per gallon, how many gallons does it take for me to go 300 miles? How do you do that conversion?
Yeah.
How'd you know to flip it over? Like, what was your clue?
Well, we get the wrong
That was good. Cancel, right? You've got 300 miles, right? And you want to turn this into gallons of gas. Yeah? The units on this thing are miles on top and gallons on the bottom, right? See that? So I put the unit I want to convert to on top. And the unit I want to convert from on the bottom. And then we can cancel the miles, right? This is like chemistry 101 or something.
Yeah.
So I should get ballpark what?
10.7.
Sure. Okay, so there's A. It takes about 10.7 gallons. Cool.
Yeah, I got those.
You got that one?
Is the answer for these kind of questions just going to vary slightly from person to person depending on what they see? Okay.
Yeah, of course, I made some guesses, right? I made some approximations. I personally probably would have gotten 10 because I'm really lazy and I use this symbol robustly. Right? If you guys want to use this symbol more precisely, go for it. But yeah, there's going to be some rounding on it. What's part B? How much gas is saved by traveling 60 miles per hour instead of 70 on a 200-mile trip? Okay, so we're going to go how far? 200 miles, right? And we're going to do that at 60 miles per hour
Instead of 70.
or at 70, and then we'll check the savings, right? Okay, so 60 miles per hour is going to correspond to what in terms of fuel efficiency?
Almost 30.
Yeah, I think 30, give or take. And 70 miles per hour is going to correspond to what? 27?
27, 28.
You're sure?
Yeah.
Close enough.
Okay. And now 30 miles per gallon over 200 miles makes what?
30 miles per gallon over 200 miles makes.
Makes, give or take, 7 gallons.
Yeah.
And 200 miles at 27
It's like 7.5 basically.
makes basically, sure, 7.5 gallons. Right? So what's the fuel savings?
0.5.
Yeah, half a gallon. And really, if I'm doing a good job, I'm not circling half a gallon. What am I actually doing here? What should I be doing?
Writing sentence.
Yeah, I should be writing a sentence, like a person, right? So, you say half a gallon. Cool? It doesn't have to be a Pulitzer Prize winning sentence, right? But the sentence is a good idea. Cool? Questions? All right, how about C? What's C? According to this graph, what's the most fuel efficient speed to travel? Explain.
55 or 56, because that's what it shows.
Yeah, that seems like, I'm looking for this spot, right? I'm looking for the top. You guys see that? Here's actually a thing worth noting. This bears into today's stuff. So over here, what's happening to my fuel economy as I go faster?
Goes up and down.
You guys all see that? So as I go that way, the function's going up. So this is what's called increasing. Right? As you go right, go up. How about over here? It's decreasing. What's it doing in the middle?
Staying the same.
Yeah, it's kind of flat for a second.
At a peak.
It's like staying the same. This is the whole idea behind probably a third of calculus problems. That the peak happens in the interim between increasing and decreasing. Right on the cusp, when I'm no longer going up or going down, that's where I should look for interesting stuff. That's where the tops and bottoms of things are going to happen. So this guy here is kind of important. Cool. That flat spot there.
Is it flat? I mean, I don't,
Perfect question. Is it flat? Philosophically,
No, it's just a point. Isn't it?
kind of. It's just a point, so it can't really be flat, right?
right.
Like, there's only one spot up there that I'm saying is the top. So it's not really flat, but for just an instant, right? It's not going up or going down. Hence flat? This is a good philosophical question. And I don't have a great answer for it.
I was having a little bit of issue with number 43.
Okay, cool. Any other questions on this one?